Hi, my name is Savannah Stampf. I'm from City University of London, and I'm going to talk to you about 5 things you should consider when bringing AI to accessibility. My background is mainly in HCI, but I have also published in machine learning. Particularly, I'm interested in explainable AI and also diverse users, and that brings me to accessibility. So what I'll be talking mainly about today is my experience working with people who are blind or have low vision in the Orbit project, but these 5 points are also applicable to other user groups who have accessibility needs, and I'll be drawing on other projects I've worked on as well. I thought I'd just give you a brief overview of the Orbit project, what that is about. So in that project, we were collecting a large open source data set to develop teachable object recognizers using few-shot learning. We involved people who are blind or low vision in collecting that data to train these models. We are running baseline analysis on this data set, and then also we are developing new models to improve on the state of the art. Another aspect of the Orbit project, which I won't touch on as much today, is that we also implemented an AI for accessibility curriculum for people who are blind or low vision to educate them more about the possibilities of AI and the opportunities that brings to the blind and low vision community. So let's get started on the first point. And the first point I want to make is that the problem is not the person, it's the need that is unmet. AI is often seen as replacing a lost sense. So for blind people, it's given them some vision to fix them, to solve what is considered the problem with them. However, I think it's worth considering a different perspective. So they have abilities and they have needs that they have, and it's because these needs are not met that they become disabled in some way. So the unmet need is the problem, not the person. In my work, I have taken that as an inspiration in terms of thinking about not just giving blind people vision to fix what is wrong with them, but perhaps giving them more than that to enable them and empower them even further. And I'm secretly on a mission to turn people into superhumans. So if we think about LaForge from Star Trek, his need was that he wanted to see, but his ability was actually that he could also see in ways that other people couldn't, and that empowered him. So think about, not just fixing people, but what is their need. The second point I wanted to raise is to get an interdisciplinary team to tackle the problem. AI, as any other technology, is really a socio-technical systems. So there are usually 4 facets to this: technology, context, people, and task. All of these are interlinked, so the task is shaped by the context in which it takes place, and the task is also shaped by who the task is performed by, who are the people performing that task. And ultimately, all of these things also have an influence on the technology. So how the technology is designed so the task can be done by the people in this context. And what you need is people who understand these different aspects very deeply in your team. So for example, in the Orbit project, we work closely with people like myself from HCI, but also accessibility specialists and machine learning experts who can bring their respective skills and knowledge to the table in order to develop this teachable object recognizer for people who are blind or low vision. So you need all of these people involved to shape a good solution, to shape good technology. The third point is really understand what user needs to solve, and don't just design technology in search of a need. In our work as part of Orbit and also in other projects, we have come across some really good examples of what people want and need, and the context in which that is produced. So I'm going to run through some of these examples. So the first one is that one that I came across in a talk with a community group. And the need was, well, I'm making a sandwich, I'm taking the bread out of the bag, but I need to know whether the bread is moldy, right? And when that was sort of mentioned as part of the community group, people were like, oh my God, this would be brilliant. So a moldy bread detector would certainly be one of those killer apps that could be produced. Another example is, well, I'm walking along with my guide dog and I need to clean up after it's done its business in the park. Obviously, that is very important, cleaning up after your dog. But if you imagine any of the sort of object recognizers that are currently available that are trained on ImageNet, I'm not too sure that any example of the object of interest here are in ImageNet. So we have a shortfall of what these things can provide. Another example is I'm finishing a meeting with lots of other people who are blind, and quite often what happens is that canes get muddled up, and then it's a sort of, well, you know, you spend another half hour trying to figure out whether the cane is yours or somebody else's. So that also came up quite a lot. So how would we detect items that belong to a person or that belong to me? Another example that we have come across is people might want to go out on a walk and they want to see what wildlife is around. So, you know, as you're walking along, can you spot any birds, any other things that might be of interest as you go along, and give them a little bit of a description, but also a little bit of context maybe. And then finally, we've also started to investigate the sighted guiding. So when a sighted person walks with a person who is blind or has low vision, to guide them or to navigate from one place to another. So one thing that can happen, and here's an example, is that I'm in a grocery store with my sighted guide, but she has just disappeared. So she stepped away, and the person is wondering, well, what is happening? What is going on right now? So how do you find out about these needs? And there are various ways, and I'm just going to show you a few of them. So I'm not too sure if you're aware of this data set called VisVis that is around. It's a question answering data set. So people have provided pictures, blind people have provided pictures and asked a question about it, and other people have answered. And you can use that for machine learning purposes. And that question about, is that bread moldy, is in that data set. And there's obviously other examples of needs or people, what people want to know in this data set. Another way that we've explored needs is through charities that we work with and support organizations. So we've been working very much with an organization called Victor that supports young people who are blind or have low vision. And they've been running an app competition as part of British Science Week recently. And so one of the ones that came out of it is this wildlife spotting app that a 13-year-old boy called Jamie suggested. And then finally, we've also done some other work as part of PhD studies where we're investigating the sighted guiding experience. And you can, of course, read that. We have a CSCW paper forthcoming about what is happening in the sighted guiding experience that might get problematic, and that might need to get repaired, and how AI perhaps could play a role there. So potential technology solutions for these are manifold. We could just think about doing object recognition, but it could also be personal or teachable object recognition. We might want some object state detectors, activity recognition, activity narration, but really these technologies are there to fulfill that need rather than being developed and then looking, well, how can we apply them in a way that is useful for this target community. The fourth point is to deeply involve your target community throughout the development pipeline and understanding how the technology will be used. And I'm going to go through some lessons that we learned from the Orbit project that I think will really be applicable to anyone working in that space in terms of developing AI solutions for a target community. The first point really is that it's really hard for people, for users, to imagine what this technology can do and how it can be used without having an app in front of them. So we try to explain it in Orbit as best we could, what a teachable object recognizer would eventually be able to do, but also what it might not be able to do. And the crucial part there is that the data that we collect from users needs to reflect how the technology might be used. So you have to create a scenario of use that says, okay, if you're using a teachable object recognizer, then you have to register the object first, right? And you have to teach it. And then you have to imagine a scenario in which that app that you haven't yet developed yet will be used. So how would they use this teachable object recognizer? Would they point at thing? Would they perhaps pan across a scene? And that really will also reflect how you will need to not just develop that model, but also how you would evaluate it. So that's the first kind of thing. And then really from then on, everything sort of falls into place as well. So for example, in the Orbit project, we know that people who are blind take photos, but they might not be usable by machine learning. So we know that there are various issues with photos taken by blind people. So for example, they might be blurry. The lighting conditions might not be that great. We also might not have the object that they want to teach the machine learning system about, that it might not be in frame at all or only partially. So we have to really think about that and consider how we consider what the user is able to do while still making it useful for machine learning. So in the Orbit project, what we actually decided to do is switch from taking images, which are really tricky, to recording really short snippets of video. So that means that there's a chance that the object will actually be in frame at some point in the video, and perhaps we can make use of the sort of temporal information in the video as well. You also have to be mindful of what and how much data you need to collect. In Orbit, we needed a lot of user-centric data. So it wasn't the case that we could have just one example provided by a user and spread the load over many users. We had to have lots of objects, lots of videos by one user. So we have to sort of be mindful that, where is the boundary? What is still okay for the user to provide, and then how can we use that in machine learning? As part of that whole exercise, we had to give detailed user instructions of how to take these videos, and that was really important. So it was easy for users to do, but again, useful for machine learning. So we get good quality data to leverage here. What was also important, and that brings us slightly back to the curriculum of Orbit, is that users kind of need to know a little bit about machine learning to produce useful data. So, for example, we found that quite often users and data collectors omitted to collect what we call test data to evaluate the system. And therefore, what they needed to know is that there is a difference between training data and test data, and how machine learning models are evaluated. So we had to tell them a little bit about that. We also found, unsurprising perhaps, that recruitment is really hard. So we had some lofty numbers that we wanted to achieve, but we fell considerably short of that. Not that we didn't end up with a really extensive data set, but we just found it hard going. And also it can be expensive. So we had quite considerable feedback that people wanted to be compensated for their time that they spent, and that needed to be much more time than you would say pay an MTurker, at the going rate. So it can be much more expensive as well, and you need to kind of plan that in. And one other thing that we learned from doing Orbit is that we needed to have a data collection infrastructure in place that was robust. So we developed it specifically for the iPhone, that is accessible. So again, we followed all of the accessibility guidelines and spent a lot of time testing it with users as well. And also we needed to ensure that the privacy of people was protected there. So we had a whole procedure that involved a researcher watching all of the videos that were coming in to make sure that no personally identifiable material ended up in the data set, and we had a validation procedure around that. So if you think about collecting a large data set, this can be really resource intensive. So that's another thing to consider. And then finally, I wanted to point out the need to figure out how to give back to the community. So there are potential solutions around that. I think co-designing with users and with the community very early on is definitely something that I would encourage. But one of the things is also that the co-design techniques that are very familiar to HCI people break down when you try and deploy them with a community, like with people who are blind or low vision. So you have to adapt your co-design strategies and techniques quite considerably to still make sure that they work. Ideally, you want to get prototypes out as early as possible, but of course that might not be feasible in the project timeline that you have. And also the quality of these prototypes might be really poor. So you have to think about, well, can I at least put a demonstrator out there that shows what it might be like, or even perhaps have a low quality one that is better than nothing. Also consider that you might have some extras or provide some extras that help the community. So as part of our project, we gave community talks. We work quite closely with charities to give lectures and educate the community. So there were these extra benefits that we provided to give back to the community. And a last point here is obviously that you can't do what I call drive-by data collection. So you can't just parachute a researcher in, do your study and then hightail it out. You really have to get the community involved, be prepared to work with them quite closely and give back to them. So this is the end of my talk. I've just put the 5 things you should consider up again. So the problem is not the person, it's the need that is unmet. Get an interdisciplinary team to tackle the problem. Understand what user needs you have to solve. Don't design technology in search of a need. Deeply involve your target community throughout the development pipeline. Understand how the technology will be used, and then figure out how to give back to the community. So thanks again for listening, and hope you enjoyed this presentation.